All right, Mike Hoffman. What a guy. All right, so Mike Hoffman, I'm supposed to do I have the bio. It's like very straightforward. You're very humble. I've been in this for 20 years. I built coffee. Look, like I'm gonna do a little bit more than that. So Mike is someone I've known for quite some time. I'd love to take credit for any of his knowledge by saying that he was a 515 alumni, but if you look at his experience and everything, I think he was bringing more to the class than he was taking away from it. But Mike was over at Shell for 20 years. Starting off as actually a control engineer and working throughout a wide variety of jobs there, even rolling out network monitoring projects and getting deep into the cybersecurity world of ICS. We're pretty proud that he is at SANS in the instructor track. I think we're actually fighting over him, if I'm not mistaken. I think Tim's trying to coach you to 612 teaching. I'm trying to push you to 515 teaching. And then as of 2 days ago, he joined us over at Dragos, or yesterday. So Mike's been around the block. He brings a really, really good point of view. And what I like about Mike the most is everything for him is absolutely community driven, education driven. How do I make this relevant to people? And so we've had him before speak at SANS. Last time at the actual summit, maybe it was this one or the last one, up on stage actually showing here's projects and kits I use out of the class. Here's how to make it actionable. Here's how to work with it. I think that's very much in theme with what he's doing now post the 612 class. So hopefully you take quite a bit away. Would also flood him in Slack with a bunch of questions. The guy's smart. He's just a good human being. Mike, over to you.
Hey, thanks so much, Rob. Really appreciate that warm welcome. And yeah, just kind of get into the presentation here a little bit. Turn my monitor up a little more. So really what this is about is, again, the topic is, what's cooking really? So what are you doing for do-it-yourself automation projects and security projects? And so the whole premise of this is really to think about what are the things that you have, maybe laying around, maybe from class, maybe from places of work, where you've worked and those kind of things. How can you further implement those into little projects, not to build a project, but to further yourself, to further your career, to further your knowledge base, and also to get back to the community, to share in what you're doing. So that's really what the premise is here. So again, yeah, who am I? So very, very blessed and fortunate to have worked in two amazing companies. Just leaving Shell after 20 years. Really, really appreciate all that the time there, the people there, and all those kind of things. And now, really, very blessed to be joining Dragos and to further, the community, to reach out, to support, to better support yourself and SANS and other places like that. So yeah, I do have, past, I kind of came from the plant floor, if you will, as an instrumentation and electrical technician, moved into analyzers, both process and environmental. From there, I found my niche in automation. Absolutely love automation. And of course, after some time, we began to connect everything together and began to ask the question, is this right? And is this secure? And so I began to get into security a lot more. And so I've been in a global role since then. And it's kind of what I'm doing in Dragos as well. A couple of certifications I picked up along the way. And then also I'm in the master's program, almost finished. So doing the last push this fall, probably will spill over into 2021, but looking to have that finished up. And yes, I'm very, very eager to begin with, or to keep moving forward with SANS and teaching, giving back to the community, and just growing this space. Just absolutely a passion of mine. So let's move back here. So again, the objective of this talk is really to, at the end of the day, encourage you. So encourage you to continue to build your competencies in protocols and automation, all those fields and those kind of things that we delve in. Of course, it's a really, really big field when you get into it. There is no such thing as a subject matter expert in ICS. There's too many particularities about it. So, but nevertheless, let's keep moving forward. Let's keep growing ourselves. And it's also to provide a way, again, to use automation kits you have laying around. For instance, here's an automation kit, a little Raspberry Pi. Traffic lights aren't on it right now. But from 515, if you have these laying around, use them. I actually integrated one of these with a Click PLC from 612 here in another project, and was able to actually control them from back and forth. Nevertheless, though, it's fun to control lights, but it's also a lot more fun to control, things that have a little bit more physical impact. And that's kind of what I did this summer. Actually, I built a coffee roaster. and used a lot of the components from the classes, and then also used again just some general automation components. And part of it though was, yeah, it was wanting to build something, but it was to give back to the community as well. So this talk is really to go over the design of that. So if you go down this path, what can you think about from designing it, building it out from the hardware perspective, programming it, and then also, of course, security. Can't talk about automation without security, especially in this venue. So again, why do-it-yourself automation projects? Well, I think this year really brings it to home. Of course, having lived my life in oil and gas, I can definitely tell you that this year has been absolutely one of the hardest years. Normally what you'll see, especially in an integrated company, upstream will have challenges where downstream has good margins and will make money, or vice versa. Lubes business or different lines of business will normally support each other throughout, hard times. This year has been fundamentally different. This year, you've seen the whole industry, because of supply and demand issues, those kind of things, the whole industry is suffering. What that means for us, security projects have suffered, training budgets have been cut, and all those things. So while our industry or this industry struggles, we don't have to struggle though in our career path and our career growth. We can still move forward. And it's also to reinforce learnings. A lot of us have gone to SANS classes and stuff. We've gained all this knowledge, but then we go back to our places of work and we may not utilize it. And what you don't use, you'll lose. And so this is really important too, is if you want to go down a path, you want to better yourself or to continue that knowledge, you need to use that. And so building out a lab either at home or at work is a great way of doing that. It's also a whole lot of fun to see a project from inception to creation, actually to see it working. I think a lot of us were, because we work in a little area where maybe we're just securing something, or maybe we're just, we're in parts and pieces. We never really see a full project from thought, perception out to full creation. And also, it's a whole lot of fun to talk to this, about when people come over with this little roaster I did. It provides something to have those fun discussions with and just chat about as well. So it's a lot of fun as well. So when we go into this, you have to ask the question, so what can be automated? And I'd argue almost anything. Now, of course, you can, but maybe you shouldn't. I'm familiar with the Red Green show, older Canadian show, and I absolutely love it. Red Green would automate almost anything with duct tape and other things. Maybe you shouldn't do that. However, when you look around, though, there's so many things that we deal with in our homes and in our jobs, those kind of things. You look around, they can certainly be automated. You think of that oven roaster there. You can automate it very easily by measuring the temperature, controlling the voltage to control that temperature in that oven. If you've taken part in ICS Net Wars before, where we're baking cookies or pretzels, depending upon the part of the world you are, absolutely you can do that, and it's kind of a fun way of doing it. But before you go down that path, you have to ask yourself, what am I going to gain out of this? So sure, you can automate something, but what is the value out of it? So always have that in your mind, is what is the value? Do I want to learn a new protocol? Do I want to learn, PLC ladder logic? Do I want to learn, function blocks? What do I want to learn out of this? And what can I take away from this? And then what can I continue to build off of this too? Don't just make it a one and done project. Make sure that it can be continuously improved upon. You can put new solutions into it, monitoring solutions and what have you. Also, think small. Big gets expensive, and this is true in most things. So if you're thinking about larger systems and larger equipment, the cost can go up. Now, again, so some other examples here: lighting. You can automate lighting. Kind of getting a little geeky here with Dragos. I just love it too. I'm kind of Dragos or a Lego maniac here, but how they've automated a Lego city. That's just awesome. And then, of course, Austin Scott's drinks mixer, a lot of fun there where you can actually automate your drink mixing. So again, sky's the limit. But before you go down that path, think about what value and what are you going to gain out of it. And with that too, think about what your budget is. All of us have a budget, and this budget is a time and money budget. All of us are busy. And so anytime you do these kind of projects, it does cost. And so it costs from a time and perspective area. So think about project management when you get into this. Set yourself some boundaries, some time boundaries, where, if you think, okay, I only have, 40, 80 hours to spend on this, that's fine. So begin to scope your project in that area. And then also from a budgetary perspective, scope your project from how much money you have. These things can get scope creep pretty easily when you begin to get all the little parts and pieces and you put it all together. So just be aware of that, try to make a plan and stick to it. So another important thing when you're designing these projects is to look at what the process is. Now, this isn't just as important for doing these DIY projects, but it's extremely critical for us as security professionals. When we go into a plant or when we're supporting our sites and those kind of things, you always have to keep context in mind with security. We don't just secure things for security's sake. We're protecting a process. We're protecting our critical energies, critical sectors, those kind of things. We're protecting physical running equipment. And so we have to learn the process in order to properly apply those controls. Well, the same thing applies here when we're building out these little DIY kits. So first of all, what I began to do is, of course, coffee is an easy thing to build out. I love coffee from the Northwest. Of course, it's very popular, US. So I wanted to, first of all, understand how coffee was roasted before I could actually control it. And this is a critical point here. So with coffee, of course, it goes through multiple different stages. And this is where you get your light, medium, and dark roasts. And it actually goes through multiple stages where it goes to a first crack at a certain temperature, and then it goes to a second crack. And between there, you're getting a medium to a dark roast. After second crack, you get into the Italian and French roast. And then after that, it gets to carbon and you catch fire. So, and with that, it's a fairly small temperature range. But if you look at how coffee is actually roasted and the temperature gradient through it, you begin to see, at least from a controls perspective, that this looks like a ramp soak type application. Not quite, but it's very similar. So I began to think, okay, I need a ramp soak type program in the PLC to pull this off. So again, by understanding the process, then I began to understand in my mind how to automate it out. And also, of course, when the beans are roasted, they also get lighter, about 20% lighter. So as the beans are roasted out, you actually need less airflow on an air bath type application to get the amount of energy out to do that proper roast. The next critical piece too is then, okay, so now I understand how to, or what the process is like. So is there any of equipment out there available to roast it? This is important because you've already identified that, okay, I want to control or want to measure temperature. I want to control the power to it. And I also want to regulate the fan speed for this. And so then you begin to go down the path of, okay, what is available out there that I don't have to come up with all this myself, but yet I can have a good base for the roast. And so here you can actually, I begin to look into it. Some of these products, looked perfect, but at the end of the day, didn't have enough specifications on like the fan, how much the fan drew, what kind of voltage on the fan, that kind of stuff. And so I actually chose that fresh roast roaster in the top right picture, if you will, the black one with a little container that looks like a handle on it. That one seemed to be the right one, but I was actually looking at that and a larger one, but the larger one would actually take 20 amps. And for those who in the US, 20 amps at 120 volts, that's a full load on a circuit. It's almost maximum for that circuit. And so I wanted to also have my control cabinet in the same circuit. So I had to go down to a smaller size roaster, again, due to utility and power requirements. So it's always critical that once you begin to look out the equipment you want to control, you have to take into account the utility requirements. It's really important because you don't want to order something and have it show up, and then you have to go rewire your house. So take that in mind. So from that, that begins to form your requirements. So with this, of course, I wanted to have multiple roast levels. Always having the same roast level, meaning medium or dark, is kind of boring. So you want to, and also different bean types, you want to have different roast levels for those beans. Normally, Colombian is a lighter roast. And some roasts from other origins, you want to roast them darker. They're just more attuned to that. Also, I wanted to have automated temperature control. Again, I wanted to have, with this to me, this is a proportional integral derivative type control. And I wanted to make sure that I had a PID loop in the PLC. I've indicated I needed to have automated fan speed. So I wanted to regulate that fan speed throughout the roast. Additionally, I wanted to reutilize, again, the components from an ICS class. So I had the Click PLC that I had the base processor from, and one of the IO cards. I had to get some more for the application, but at least I had a good basis for this. Again, one of my requirements also was not to rewire my house, but was to utilize everything had to fit within the headspace of 20 amps. I also wanted to put it in an enclosure because I didn't want to have it, dust and those kind of things. This is definitely an area where you could go and it could be a little bit cheaper for you. But again, for my requirement, I wanted to put it all in an enclosed panel. And then, of course, you can't do this without security. So I wanted to make sure that I had secured remote connectivity to it. I roast out in the garage so I can access the PLC remotely, wirelessly. And then also, doing full packet capture between the communication from the PLC and that remote device, which I'll talk in a minute. So here is kind of beginning the build phase. I've selected that SR540 roaster and began to take it apart, do some voltage measurements on it to understand, okay, what does the motor require for current and voltage, and also how much that heater requires. Did some ammeter checks and that kind of stuff. And then, of course, beginning to, with that, it gives you the baseline for getting your other components. So, of course, it's a DC motor for the fan, so I need a DC motor drive. And then you begin to lay out your requirements for how much 24-volt power supply you need, and those kind of things. So begin to take that apart. And I know this is a very scary stage for a lot of folks, is you take something, you just bought it and it works, and I'm going to make it inoperable. So I can make it operable again. So it's always a scary stage when you start throwing circuit boards away, but yet, nevertheless, it needed to be done. Also, I needed to get a lighter size or an 1/8 inch thermocouple. In that course, it came with a 1/4 inch thermocouple, which proved to be way too slow in this application. And that was just due to the metallic mass of that extra large thermocouple. So I needed a smaller thermocouple to respond to temperature a little faster. Of course, and it's also been brought up a little bit earlier today, is you may want to consider some other areas for some of these parts. You don't always have to go to like Automation Direct or another company. Absolutely, I tried to do that just to simplify the build. But if you have some companies, not all, but some companies will actually allow you to take used equipment out of the site if it's being if you're doing an upgrade and there's some PLCs left over in a control cabinet. You may in your company have the ability to use those. So I'd suggest when you go down this path, look around for some less expensive alternatives. So here is beginning to set the panel up and to wire everything together. One of the key things here is read the manuals. Every manufacturer has a different wiring specification, and even between circuit or IO cards on a lot of these devices, you may have two different analog input cards or something like that, and they're wired slightly different. And so always look at does the card provide power, or is it taking power, syncing versus sourcing? It matters a lot on how you wire these things. I would recommend really doing that before you turn it on and do a smoke test on the device and end up having to buy another card. I've done that more than once in the past. Use the right wire gauge. So it's always important for just ampacity and safety. Uses fuses are required to protect the systems that you just purchased. Another important aspect is to separate your AC from DC circuits. So in here, of course, in this little control cabinet, I'm utilizing direct current for the motor and all the power for the PLC and the inputs and outputs. But AC is powering, of course, the other components. And so in these cabinets, you don't want to have them together. It's electrical interference, but it's also safety. So as you're, troubleshooting or something like that, and you have your hands in there on when it's powered on, you don't want to touch the wrong wire and get shocked. And so it's always good to separate your AC/DC. Use terminal blocks or Panduit just to keep it clean and tidy. I was trying to do that on this again, just to do yeah, best job. So programming is where it begins to get a lot of fun. So this is where you're actually taking all of those other concepts from designing this out. You've wired up your loops and those kind of things, and now you're actually implementing the logic. The way the logic actually worked here is, and unfortunately due to the slide length, I'm not able to show the HMI, but the HMI and this one, what it has capability of is selecting the right roast program for what you want to use, a light, medium, or dark, or even a manual roast. And so from the HMI, you can select the roast program. Here, I'm selecting number 3 program, which is actually the dark roast. And so what that does is when I select 3 on the HMI, the rung turns true. And then I'm going to copy a block of values from the registers. And that block of values is pre-programmed for dark roast. And what that'll do is that's time, temperature, and fan speed. And that's dropping all those into my running scratch pad, if you will. So I'm doing a one-shot copy of those values, and then I'm ready to begin to roast. So what happens is after you push the start button on the HMI panel, it'll start out the roaster timer. Again, all these times are derived from the preset values in the program. And then of course, once that timer begins to time, I also have a latching bit to keep that timer running. Again, different PLCs will have a different, some of them will have a latching bit on that timer itself. Yeah, on this one, I actually had to create my own. But nevertheless, using a latching timer to keep that timer operating throughout the cycle. And again, right when the cycle begins, initially what I want to do is put in a starting value to begin to dry the beans out, and put the fan speed to 100%. So I want to dry the beans, fan speed to 100%, just to get, during that first initial stage. After 60 seconds, the beans are beginning to dry out. Now I start to crank the temperature up. And so here at 60 seconds, it goes to 350 degrees, fan speed still 100%. And then I continue on to the second stage. At 150 seconds in, now I'm beginning to ramp the temperature up to 420 degrees. And this is where you're going from a lighter roast, or almost a blonde roast, into a light roast. The bean size at this stage doubles, and then the weight drops 20%. So at this stage, I want to reduce the fan speed by 10%, and actually on this device does quite a bit. So it allows it to control properly. And so again, just watching the program go. At 300 seconds, now I'm ramping it up to 460 degrees Fahrenheit. Apologize for other folks. I probably should have done this in Celsius, but nevertheless, it's in US units. So 460 degrees, this is where you're getting into the Italian and French roast. If I were to let this go a couple seconds too long, it starts to smoke. The oils are coming out of the beans. And again, you can, your beans quickly go from dark roast to extremely dark roast to carbon to fire. So you have to watch this one. So when you roast really dark, you actually have to manually turn it off at the right time. It's been a challenge to try to automate the shutoff process. You'd actually have to implement a little bit more instrumentation around it to do that. So finally, at the end of the roast, the your running bit goes down. That timer would time out, or from the HMI panel, you turn it off. And then from there, of course, your cooling timer begins. And at the same time, you change your set point to your PID control to 0, because you're entering the cool down phase. So you don't want to drop in your set point to 0. Of course, you can always change your PID loop to manual and then shut your output to 0. The Click PLC, I was having some problems with this doing the auto to manual. It would work sometimes and not others, so it's just easiest to keep it in auto and turn the set point to 0. Of course, fan speed 100%. Again, trying to cool the beans as fast as possible. When that's done, the cooling bit shuts off. So I'm triggering on the bit going from true to false. And then, of course, at that time, the fan speed shut off and the roast is complete. This is kind of how it looks like on the PID control loop graph. And so it's kind of a ramp soak type operation here. At the first instance where you begin to start the roast process, you can see the set point value in the red pin will move up. And then you can see the temperature tracking that. And then the second set point value, it moves up. Now, with this, you have to keep in mind that when you tune a PID loop, you're tuning at a certain area in the operating range of that. And so if you tune in one certain area, you may get really good control. If you tune in another area, the control is okay, but not the best. And this is very much similar to any type of process, and process control engineers will tell you that, you always tune at where the process normally runs. And so for me, I actually tune this thing at around that 375-degree range, and it controls fairly well there. When you get outside of that area, you'll see a little more under or overshoot. That's kind of what's happening here. You can kind of see at that final set point change, when it gets really, really hot, the output, the solid state output through the heater goes almost completely to 100% on. And what this means is that you're at the end of its control range, the controllability. So any more than this, your roaster would, or the roaster couldn't really control to. Your control gets pretty poor. At the same time, though, I don't want to take it much past this, because it's kind of a safety issue, and I'll probably destroy my roaster and cause a fire. So anyway, just be aware of that when you're playing around with this, always think about the controllability range of the device. Of course, needed remote access. So what I wanted to do here is utilize some stuff that I had laying around. I did have a Raspberry Pi version 4, and those things are incredibly powerful little computers. So if people are used to the version 3, the version 4 did quite an upgrade on that. So I actually had one laying around, and I used that as a network access point and a bridge, connected up to my home network and did some routing in there. And then also I had a spare Moxa firewall laying around, and yes, I did upgrade it to fix a vulnerability in it, secure that communication down, and also used the Raspberry Pi for network monitoring. Now this is a solution I want to further build out. And again, you always want to leave something in your project so you can kind of further develop yourself. So definitely, probably this is a little too small for a Dragos platform instance, but I can definitely use Sophia here or something like that. Free tool to put on this little Raspberry Pi and actually monitor real time the traffic going back and forth, just to make sure my neighbors aren't manipulating my roast. And so always important there. This is kind of what it looks like, and I would say a nearly complete project. So again, you can kind of see the roaster with the panel, and yes, I do use this about every other day. So it's just a lot of fun. Kind of see the inside of the panel here, a little bit more busy with all the networking components in there and that kind of stuff. But at the end of the day, that's kind of what I came up with. And that's kind of where it stands now. And again, as time allows, I'll do a little bit more on the network monitoring piece. So in the end, look around. You have so many options to really get into this, into these projects and that kind of stuff. And so I'd really encourage you to, if you do have devices from class, if you have devices that you can get your hands on from work and those kind of things, do it. And continue to grow yourself, continue to grow your abilities, and then share back with the community. I would say, roasting coffee is very nice. It smells really, really good. So it is something that, after a stressful day, it's nice to go out and actually utilize the project that I put together. So I would caution you, though, when you go down this path, like I said, it takes time. So make sure that you have some time for it. It does take money. So make sure you're budgeting for it. So again, I've spent at least 80 hours on this project. Again, it was over a period of on and off time throughout the summer, and of course, total project cost was around $1,200. I could have definitely gone down on that. I do tend to over-engineer things, but nevertheless, it's really fun to see a project where you've thought about it, talked with colleagues about it, and then you actually go build it and use it. So with that. I do have all the documentation for this project. It is out on GitHub, and right when I kind of pop off of this presentation, I'll post that link in the hallway chat for you. But definitely encourage you to pull that down, and if nothing else, just look through the code. I do have a fairly lengthy document in there that has all the diagrams and those kind of things, so you can, if nothing else, kind of get more familiar with the PLC program, HMI, and then also all the wiring and so forth. So I do greatly hope you enjoy this. I do miss you folks a lot and look forward to the next time we can connect face to face. But until then, thank you so much.